I'm Carl Anthony, and welcome to AutoSens, the world's leading community for ADAS and autonomous vehicle technology development. We create best-in-class training, events, and information to connect engineers, scientists, and automotive industry experts across the globe. Today, we're speaking with David Imrie, the Chief Technology Officer for Optikos Corporation. David, thank you for joining us and being part of AutoSens. Welcome.
Thank you, Carl. It's a pleasure to be here.
So, David, let's just start at the beginning. Give us a high-level overview. Tell us a little bit about Optikos. Tell us about the company.
Well, Optikos is a company that is currently celebrating its 40th year in business. We have two main business areas. The business divides into services and instrumentation. On the services side of the business, we offer engineering services where we'll design people's products for them, anything with an optical element to it. We do complicated lens design, but we also do very sophisticated optical systems designs. In the services side of the business, we also offer contract manufacturing, which is the part of the business that's becoming significantly more important, where we'll build either products that we've designed for people, or we'll build designs that other people have put together themselves. Those builds can be very sophisticated builds of lenses that have to be spun out on air-bearing tables, or they can be lenses that get assembled fairly quickly in high volume. Our advantage there is that we offer the ability to test a lot of the stuff that we build, because our instrumentation side of the business is all about testing. We've been manufacturing test equipment for the better part of the 40 years that we've been in business, primarily focused on measuring the performance of lens and camera assemblies, the imaging quality that you get out of a lens. The metric that's primarily used is the modulation transfer function. So a lot of our equipment is designed to measure the MTF of lenses. Historically, that was driven by the defense industry, who needed to measure the performance of lenses. But more recently, we found that the consumer and automotive sectors have become increasingly important.
Yeah, so let's talk about that, David. So you have 4 decades under your belt and experience from the defense industry. So taking all that now to the automotive imaging market, what role does Optikos currently fill in the automotive imaging sector?
So a lot of those products that were initially developed for the defense sector were designed to measure lenses that were fairly big, because that's typically the nature of defense cameras and lenses. So infrared cameras and visible cameras and lenses. In moving to the automotive sector, we've taken those products and we've scaled them down, because automotive lenses and cameras are obviously substantially smaller. So there's a lot of miniaturization that's happened in the products themselves, but the basic principles that are used are still the same. So the product offerings for the automotive sector also divide into measuring camera performance and measuring lens performance. On the lens side, we have a turnkey instrument called the lens check, which is a benchtop MTF measurement station. It can measure on and off axis and is widely adopted by many of the lens manufacturers that serve the automotive industry. On the camera side, we have a product line that we refer to as the Meridian product line. And in the Meridian product line, there are several instruments that are important for the automotive industry. The most popular and widely adopted one is a platform that we refer to as the star field. And the star field consists of a number of collimators in a monolithic assembly, which cover the entire field of view at the field points that the customer has specified. And this is typically used in end-of-line testing in the automotive industry. It'll sit at the end of the line after the lens and the camera have been mated together. They'll pass underneath a star field. They'll take a single frame, and in that frame, you'll have multiple field points illuminated with resolution targets that enable the performance of the system to be measured across the field. So that's the star field, and that's used in production systems. In the R&D departments of automotive camera vendors, the needs are not necessarily for a specific camera, but to evaluate multiple different cameras and designs. And there we have a product that we call the Meridian Flex. And the Flex, instead of grabbing a single frame of video, grabs multiple frames of video, and we move a collimator around the field. So in principle, it's a robot that's holding a single collimator and moving it around the field to programmed field points. And at each field point, you grab a single frame of video, and then you can assess the image quality at that particular field point. From the geometry of that target, you're also able to determine some of the intrinsics of the camera itself. So you can measure the distortion center of the camera once you've built up enough frames of data. So there's geometric imaging information to be had, and there's image quality information to be had as well. There is also a product that we refer to as the FTP. It's an acronym that we've adopted as our own. We use it to stand for Focusing Target Projector. And instead of a fixed focus target, as is common in the Starfield product, the FTP allows you to place an object at any distance from the camera. So you can do through focus measurements for camera assemblies that are already bonded together and can no longer focus, and you can find out where the best focus point is in the field. And you can set targets at arbitrary distances and measure the image quality at that object distance. So those are the existing products that we have in the Meridian family at the moment. But we are working on new ones, and we'll be introducing one at AutoSens.
And David, you have brought on your desk, you've brought a product to show us. Can you take us through that here just a little bit?
Be happy to do so. So the products that we've focused on up to this point all measure the imaging performance of lenses. How sharp is the image? What's the MTF in the image, whether it's a lens or a camera? We're now moving into measuring stray light, and it's something we've been doing for a while. And it's not an imaging performance, but it's all about measuring how well stray light is controlled in lens and camera assemblies. And this is also driven by the needs of automotive customers, because you have two stray light parameters that you wish to measure: Veiling glare index and glare spread function. Very briefly, glare spread function involves measuring where light from a bright source inside or outside the field of view might end up where it's not supposed to. Most obviously the sun or headlights from or street lights or other bright point sources in an image. Veiling glare index is more about how light across the field enters the part of the field where you're actually trying to image something. So Veiling glare index is the black dot on the white background, and glare spread function is the white dot on the black background. The product that we have products that serve both of those, but the one that we're introducing at AutoSens, we refer to as our Sol 55 projector. This is a Sol 55 projector, and this basically allows you to project a bright source into the lens under measurement. And you can change the size of that source by switching out an aperture draw, which fits into the assembly here and is then detected and accounted for by the instrument. You can change the numerical aperture through that source through a wheel at the back of the instrument. And that ensures that when you're making the measurement, which has to happen in darkness, that you're illuminating only as much of the lens as you have to, and you're not hitting it with a big patch of stray light, of bright light, which would otherwise contribute to the measurement by bouncing around inside of the enclosure in which this is housed. So we have those two parameters that can be adjusted. These things can be daisy chained together. They're controlled over a network. There are electrical connectors on the back allowing you to daisy chain them. So you can put them in something like a star field, and we do that as well. We refer to that as a sun field, and you can have an array of these that can be turned on sequentially, and then you can measure the effects of a bright point source around the field and find out where the light is getting to, other than the point at which it's imaged. So that's the Sol 55 projector that we'll be introducing at AutoSens.
And again, want to encourage our viewers to see that in person at AutoSens, also to visit your website as well, optikos.com, for more information on all of the things that we're talking about. David, there's one thing I want to come back to. Off the air, we were talking about how you as a company are willing to do the difficult things when it comes to testing. You're willing to tackle the difficult problems. Now that we're here, we're live and on the air, let's talk about that a little bit more. Can you elaborate on why it's important for you as a company to do those difficult things when it comes to testing? Tell us your insight there.
Well, we do offer standard instrumentation like the lens check and a whole bunch of accessories that go with that. But something like a star field, where we're doing an end-of-line test, is customized to the camera that's actually being tested, because the customer will specify the field points that are required, will illuminate those field points. But the really tricky part of a star field is, in fact, ensuring that the target that arrives, the image of the target that arrives on the sensor, has a geometry that's suitable for making an MTF measurement. When you're making an MTF measurement on a camera, you're stuck with the sampling that the camera will give you. You have pixels that you have to sample, and so there are ISO standards to which we adhere, in which you have to present a slanting edge, and you make a slanting edge measurement, but you need that slanting edge to be at a certain angle with respect to the pixel array in the camera. Typically 8 degrees, but anywhere from 5 to 10 degrees is perfectly fine. But with a wide field camera, you're going to end up with a very distorted image. And an edge that starts off in a target projector is a nice right angle edge. By the time you get to the edge of the field, it's going to look like a very distorted bow tie. And the angles with respect to the pixel array are going to be completely unsuitable for making that sloping edge measurement. So what we do is we take the information about the camera and the lens that the customer gives us. We create a target that is the inverse of the distorted target that we know that camera is going to produce. And we produce that target and put it in the projectors at that field point. So for a wide field of view camera, we have pre-distorted targets that are suitable for the field point at which they're located. That is quite a difficult thing to do. We've been doing it for quite a while. We're known for doing it. There are lots of customers we have that have implemented this, but it's still quite a difficult thing to do. We've developed the tools to do it. We have people who've trained in doing it, but hitting all those numbers, getting that right, producing these targets, and then having the image appear to have right angle edges by the time you've gone through the lens that you're actually measuring is pretty tricky. So that's one of the things we do that gives us a real competitive advantage. And as I say, it is quite difficult. On the lens side, that's an example. On the camera side, on the lens side of measurements, the automotive industry has driven the development of another product for us, which is our range of thermal chambers. Because cameras need to be tested over a range of temperatures, as all automotive components need to be, and minus 40 degrees being something of the holy grail in that sense, which is extraordinarily cold. Measuring a lens at minus 40 degrees is quite a challenge because the rest of the test equipment is at ambient temperature. And so this is a challenge that we took on, and we've developed this line of the TM thermal modules, and there are a number of different sizes, and they are accessories to the lens check instrument for measuring small lenses. And they are very successful in doing what they're intended to do. They're a fairly sophisticated piece of equipment. In fact, to be fair, they have nothing to do with optics. They're all about thermodynamics and heating and cooling lenses, dealing with the very obvious challenge that if you have a cold lens at minus 40 degrees sitting on a test bench, it's most obviously going to suffer from condensation and frosting, which is a terrible thing to deal with when you're trying to make a measurement. So we have ways of mitigating the amount of frosting that occurs, which involves passing dry air over the lens during the measurement. The other part of the other difficult part of making those measurements is that the metric that customers are primarily interested in over temperature is simply defocus. How much does the lens defocus with respect to the sensor? And that, in technical terms, is something that we call flange focal length variation. It's a mechanical measurement from some mechanical datum on the lens to the image plane. And given how small the pixels can be on automotive camera sensors, they're very small pixels, and how relatively fast some of these lenses are, there is a great deal of sensitivity to defocus. You only need to go a few microns out of focus of thermal shift, and the image is going to defocus appreciably. So we have to make that measurement to within a micron or two over a temperature range. It's a mechanical measurement. You have to pick up the datum on the lens to establish where that mechanical flange is. You have to make sure that that reference itself isn't changing over temperature, because that's obviously in the thermal chamber with the lens. There are a lot of very tricky technical problems to solve in making a defocus measurement on the lens over temperature. And we've managed to crack that nut. It's a product that we sell. We sell it to the automotive lens manufacturing market segment, but we've actually found that since we've developed it for automotive, there are customers now in the defense industry who are also interested in making those measurements, and rather surprisingly in the gaming industry as well, but that's a bit of an outlier.
David, I so enjoy your passion and hearing from you. Again, want to encourage our viewers to visit you in person at AutoSens Brussels, and also visit your website, which I have up here on my second screen, Optikos.com. David, from all of us here at AutoSens, we want to wish you the best of luck going forward. Thank you for sharing your expertise and your thought leadership and everything that you do as a company and your experiences. And I look forward to seeing you in person in Brussels, and thank you for being with us today.
Thank you, Carl. I'm looking forward to it too.
For more in-depth interviews like this, subscribe to our AutoSens YouTube channel and follow us on LinkedIn. For more information on our world-class events and technical training, visit auto-sense.com. That's auto-sense.com. Ahead of meeting in Brussels, and on behalf of AutoSens, I'm Carl Anthony.